So we were discussing about the Thevenin's and Norton's theorem. So we will start with the problem today. So there is a network. There is a network which consists of n resistances. N resistances and constant ideal sources. So there is a network with a lot of resistors, and there are some independent sources. We can say the current I is equal to 3 ampere and 1.5 ampere when the resistance R, there is a resistance which is named as R in the network. Suppose that is equal to 0 ohm, then the current is 3 ampere, and when it is 2 ohms, the current is 1.5 ampere. That's the meaning, respectively. Okay, determine the current I when R equal to 1 ohm. So there is a network. So I will write the answer. So there is a network. This is a big network, and this network contains lot of resistances and ideal sources. Okay, and you want to find, there is a resistance which is R. Whenever this R equal to 1 ohm, that is the question. When this R equal to 1, you have to find what is the current through this. What is the current? But it is given that when R equal to 0 ohms, the current was 3 ampere. When R is equal to 1.5 ohm, the current was 1.5 ampere. The same thing, the current was 1.5 ampere. Then when R equal to 1 ohm, what will be the current?
You mean 2 ohm, doctor?
Sorry, it is 2 ohm. Okay, sorry. So here 2 ohm. Okay. So when R equal to 0 ohm, the current was 3 ampere. When R equal to 2 ohms, the current was 1.5 ampere. Then what will be the current when R equal to 1 ohm? And this is a network which contains lot of resistances and constant ideal sources. There are n resistances and constant ideal sources. So you know, when we are focusing only on a particular element in a network, then we can use the network theorems. And here, one of the suitable candidate for this is the not superposition theorem, it is the Thevenin's theorem. Okay, so we can use here Thevenin's theorem for solving this problem. So you have the network, so you can change the network, you can represent this network. This network you can represent by using a Thevenin voltage and a Thevenin's resistance. So you can represent this network like this, and your R is connected here. Okay, your R is connected here. Okay, that's it. Now you know that whenever you are representing it by the Thevenin's equivalent, V Thevenin and R Thevenin, and you are connecting here R, this is your R, then you will have the equation I is equal to, it is given that the current is equal to 3 ampere when R equal to 0 ohms. So what will be the current? The current is equal to 3 ampere when R equal to 0 ohms. And what is this current? It is nothing but V Thevenin by R Thevenin. Am I correct?
Yes, sir.
Yes.
Yes.
Now the second case, we will choose the second, we will take the second one. This one. That means when R equal to 2 ohm, that means the current when R equal to 2 ohms, okay, 0 and 2. Okay, now it is 2 ohms. the current equal to 1.5 ampere, and this current is nothing but your VThevenin divided by RThevenin plus your 2 ohms. Is it okay?
Yes. Yes, sir.
Yes. Now you have two equations, equation 1 and equation 2. And how many unknowns are there? You just need to find out VThevenin and RThevenin. So those, just to solve this equation, and you will get VThevenin. I will write the answer. I don't want to waste the time. Okay, this is 2 ohms you will get. Okay, so you can find it like this. Okay, now after finding this VThevenin and RThevenin, you can have the 6 volt here and 2 ohms here. Now you want to find what will be the current, when R equal to 1 ohm. So you are just putting this R equal to 1 ohm. Now you can find the current very easily. It is nothing but the current will be equal to 6 volt divided by 2 ohm plus 1 ohm. So this is nothing but your current, which is nothing but the 6 by 3, it is 2 ampere. Okay, 2 ampere. Is it clear?
Yes, sir.
Yes, it's very easy. Next problem is a very critical problem. Okay, very be careful about this problem.
But doctor,
yes,
excuse me,
yes,
can we solve it by you know, this is a linear circuit, and if you give you 0 ohm, you will get 3 ampere.
yes.
If you give 2 ohm, you get 2 ampere. No,
Which theorem
ampere.
which
But
theorem you will
give,
use?
because it is linear circuit, if you give 1 ohm, it will be 2.25.
So that kind of thing is, it is not like that. How you can calculate, because you have no idea about what are the sources here. What is the situation of the sources here? It is just given the constant current source. It is not given here. It is 6 volt or 3 volt or 5 volt, whatever it is. It is not given. That's why. Okay. You have no idea about it. Okay. So in some occasions, all the theorems are not suitable. You cannot use the superposition theorem, or you cannot use the principle of you cannot use the other kind of theorem. All these things you cannot use it at all the time. Sometimes you have to you will be restricted to only one theorem. In some cases you can use both the theorems. Okay, so next problem is a very critical problem. Okay, an ideal voltage source is given. Voltage source, voltage and current source. You know what is ideal current source and voltage source. And the ideal voltage source and a current source are connected in parallel. Okay, that connected in parallel. And the question is, this combination, that means the combination with the ideal current source and voltage sources are connected in parallel. This combination will have, okay, this is a multiple choice question actually. It has Thevenin's equivalent, and excuse me 1 second. Okay,
take your time.
yes, can you hear me now? It's fine.
Yes,
okay.
sir.
Yes.
So there it has Thevenin's equivalent, but sorry, it has both Thevenin's and Norton equivalent. The option is like this: both Thevenin's equivalent and Norton's equivalent. Option B, only Thevenin's equivalent. C, only Norton's equivalent. And D, neither both of this. That means neither Thevenin's and Norton's. Okay, Norton's equivalent and Thevenin's equivalent. Okay. So the question is like this. So the question, and also it is given like an ideal voltage source. There is an ideal voltage source. You can like this. This is a voltage source. What is the speciality of an ideal voltage source?
Its value will be constant. It will not change, and it has not.
Yes.
It hasn't resist. It
Yes,
has not
there is
an internal resistance.
no resistance. Yes, and there is an ideal current source. You can say like this. This is the current source which is connected in parallel, and this is the point A and B. You want to find the equivalent. Okay, that means this is I. Now the question is, this combination will be having both Thevenin's equivalent and Norton equivalent, or only Norton equivalent. You want to find whether it is only Norton equivalent or Thevenin's equivalent. We have to find it. What do you say about this? Whether it is having both or?
Thevenin equivalent, because the current can be anything, but the voltages depend on the voltage source. My opinion.
Yes, this is only Thevenin you are saying, right?
Yes, sir.
Very good, very good. That is the answer actually. So if you see from here, you are going to find the Thevenin's equivalent. Okay, Thevenin's equivalent. First of all, we will try to find the Thevenin's equivalent. So Thevenin's equivalent, how to find the Thevenin's equivalent? We want to find the V Thevenin, and V Thevenin will be equal to how much? If you see from here, what will be V Thevenin? V Thevenin will be equal to?
Same as the voltage source.
Yes, it is same as the voltage source. And what will be R Thevenin? To find the R Thevenin, you have to short circuit all the voltage source, right? You have to short circuit the voltage source and open circuit the current source. Now you see from here, the R Thevenin, how much? What will be the resistance here?
0.
If you see, it is 0 ohms. Very good. Now we will see what is the situation with the Norton equivalent. To find the Norton equivalent, you want to find the current source. So if you have something, you will find the current by like this. This is the voltage source and this is your current source, and you can find the Norton equivalent by just finding the short circuit current through this between the points A and B. What will be the short circuit current? It is the current coming from the current source plus the current through the voltage source, IV. I'm saying IV. IV means the current through the voltage source. What will be this value? Current through the voltage source?
We don't know.
Yes, any value. It can be any value. That means we will say that Norton equivalent does not exist for this case. Only the Thevenin's equivalent exists. So which will be the option? B will be the correct answer. Yes. You got it? This is the problem. So this is a very, very important concept. Okay, this is a very important concept. If you understand this, you understood the idea of Norton's and Thevenin. The next question, the question number 3, the same thing like this. In the next question, you have a circuit. You have a circuit shown below, and the circuit is like this. For this circuit, you can see here, this is V, and there is a current source which is connected in series with this. Now for this, the option A, it is given only Thevenin's equivalent, B only Norton's equivalent, C both, D neither Thevenin's nor Norton's. And which equivalent will be existing here between the point A and B?
Opposite the previous question. It is
yes, just opposite the previous question. So what will be the Thevenin's? So we will find first Thevenin's equivalent. So in this case, if you see from here, you can see there is a current source. That is a problem. Whenever there is a current source, this is the voltage V, and the voltage across the current source, I will say VI. So the voltage V Thevenin between the point A and B is nothing but V plus that Vi, but this Vi can be any value, right? Am I correct?
Yes, sir.
Yes.
Yes.
Okay. Now I'm going to find the Norton equivalent. For the Norton's equivalent, there is no problem. You see here, this is the current I. So I will just short circuit this. The short circuit current will be same as I, right? It will be same as I. And you find the R Thevenin, that is, this is nothing but your I Thevenin. And what is your R Thevenin? How to find the R Thevenin? You have to short circuit the voltage source, right? Am I correct?
Yes.
Yes, sir.
Yes, you have to short circuit the voltage source. The voltage source is short circuited. And what about the current source? You have to open
Gonna
circuit.
be open circuit.
Yes.
Open
So
circuit.
R Thevenin will be equal to how much? There is an open circuit, so R Thevenin will be equal to
Infinity ohm.
infinity. So can you got some concept from this problem? That's what my. So here Norton equivalent exists and Thevenin equivalent does not exist. So when you compare this problem with the previous, there is an important observation from this. You can see here only Norton equivalent. That means you have something here. This is the equivalent. This is your I Thevenin, which is equal to I, and R Thevenin is an open circuit, right? Am I correct? R Thevenin is
Yes,
equal
sir.
to infinity. Yes. In the previous problem, can you tell me what is the Thevenin's this Thevenin's equivalent? In the previous problem, you have V Thevenin, and V Thevenin is equal to V, and R Thevenin is equal to 0. This is A and this is B. So there is an important observation from the previous problem and this problem. That means in the previous problem, you see here, this is an ideal voltage source. So an ideal voltage source is having only Thevenin's equivalent. There is no Norton equivalent. And ideal voltage source, actually, it cannot be, you cannot change it. It is not possible to convert it into a current source. An ideal voltage source cannot be converted into an equivalent current source. Got it? Got the point?
Yes, sir.
And here you see in the series combination, an ideal current source cannot be changed into an equivalent voltage source. Got it?
Yes, sir.
So the conversion is not possible if the things are ideal. Only in the practical case you can convert it. So that is the beauty actually. So the Thevenin equivalent, you will usually represent something like this, V Thevenin, and there is a resistance. Usually you will tell like this, R Thevenin. Okay, the equivalent, Norton equivalent, is nothing but, you can say this is your V Thevenin. Sorry, there is a current source, and what will be the amplitude of this current source? It is nothing but I Thevenin, and I Thevenin is nothing but V Thevenin by R Thevenin. That means they are equivalent. They are equivalent. This is a very, very important point. And you can have a R Thevenin. How they are equivalent? Can you prove this between the points A and B?
By source
Source
transformation.
transformation.
Yes, source transformation. Okay, this is very easy. Source transformation. So by using source transformation, so you don't need another proof. By using source transformation, we can prove. This is our proof by using source transformation. I am going to prove it. Okay, we can prove this. You see here, you remember in the source transformation theorem, I have already explained to you that current source cannot be converted into the voltage source if it is ideal, and the voltage source cannot be converted into a current source if it is ideal. You remember this point?
Yes, sir. Yes.
Yes. So here also it is valid. That's the beauty of this thing. Okay. Next problem number 4. Question number 4. So this is a thing with AC. In AC circuit also this is valid. Okay, so there is 100 angle 0, you know this representation, and this is 2 ohm, it is an inductor, and there is a capacitor which is minus J6. You know why this is minus? For the capacitor we can represent like this also, and there is an inductor again J4, and this is the point which is A and B. You want to find what is the equivalent for this network. You have to find the VThevenin and the RThevenin. Okay, here you can see we have reactance, so we will represent it like Zthevenin for this circuit. What are this VThevenin? And between the points A and B, you can say between A and B. So what is the procedure for finding?
The VThevenin is same as the voltage source.
Sorry, there is I missed one point here. You can see this is 3 ohm. Okay, so we will find the VThevenin. Okay, sorry, Ryan, actually there is a 3 ohm resistance, so it is not same. Okay, I missed it actually. Okay, so you can have, this is the voltage source here, right? Voltage source.
Use source transformation.
Source transformation and all, it is not required. You know this, it's very easy thing. We are going to solve this because this is the point. You see this voltage is Vs, actually same thing, so everywhere it is Vs, so this is also Vs. Yeah, simple thing, VThevenin will be equal to, that is the voltage between these 2 points is nothing but VThevenin. You just open circuit
By
it.
voltage division.
So VThevenin, voltage division, Vs divided by, you have 3 ohms plus J4, right? Okay, into voltage division J4, and Vs is 100 and divided by 3 plus J4, okay, multiplied by J4. And you know this 100 angle 0, or this has to be converted into the polar coordinates. Then you can solve this. I am not going to solve the complete problem. I just give only the idea. So this is the this is the case. So you can get this answer as J into 16 into 3 minus J4, this much volt. Okay, you can see this is in the Cartesian rectangular coordinates. You know this thing, rectangular coordinates and polar coordinates, I hope so, right?
Yes, sir.
Yes, so this is a VThevenin. Okay, this just simplify this by using the polar coordinates. Okay, so I am not going to spend the time for this now. Okay, if you have doubts, inshallah I will clear you later. And Zthevenin, how to find the Zthevenin? For finding the Zthevenin, what you have to do?
Short circuit the voltage source.
Yes, you have to short circuit the voltage source. Then there is an inductor which is J2 ohm. There is a capacitor which is minus J6 ohm. Now there is a 3 ohm resistance, and there is a J4, and you have to look from here what is the resistance. Now you see what is the short circuit resistance. It is just 0 ohm, right? It is 0 ohm.
Yes.
So you can see 0 parallel J2 parallel minus J6. What is it?
3 plus
Yeah.
You will
J4.
cancel.
These are all parallel.
J4.
This
Zero.
will be 0, right? This path will be 0.
Yes,
The path I shown here. Now, what will be the remaining circuit? The remaining circuit is 3 ohm and
J.
J4. Yes. Then it is nothing but 3 ohm parallel J4. That will be your RThevenin. I hope that this answer is very clear to you, right?
Clear, sir.
Okay. And next question number 5. So there is a network like this, which is a network like this, and you have the voltage between these two nodes it is V, and you have a current source which is 2 ampere, and this is 2 ohm resistance. Okay, 2 ohm resistance, and you can see it is this is 5 volt. Okay, this is it. Now what is V option? There are some options are given. It is 9 volt, which is 5 volt, this is 18 volt, and D, none of this.
It can be
What do you
anything,
think?
doctor.
It can be anything. So what will be the answer? So the voltage can be, the voltage V is equal to, you have, how much it will be? It is also given here, it is 9 volt. This is 9 volt, okay? So what will be the voltage? It will be this 9 plus any value, because the current source we cannot say what will be the voltage across the current source. It can be any value, right?
Yes.
So the answer is none of this, because it can be any value. So none of these answers. That's it. It's clear?
But
Clear,
how,
sure.
how can you know it's none of these? Maybe it's one of the 3 choices, A, B, or C.
Because it
don't
is
know.
not anything, any absolute value. It can be any value. That's the problem. Any value means all the options. That is not possible. You have to select only one options. That's why. Okay.
It would depend upon the network.
It will depend upon the network. That's it. Okay.
Okay.
Because only 4 options are given, and you have to select one of this option. So 9 volt, 5 volt, 18 volt, all these are not an appropriate option, because it can be any value and you cannot select all the options. So the appropriate option is option D. Okay, it's clear.
Doctor, it wants the value of the voltage of the network.
Yeah, you have to find the voltage in the network, because there is a current source connected to the right side of it. That is a problem. This current source will, we cannot predict the current source, what is happening. Yes, so it can be any value. Okay. Now there is another question. Another question. Okay, there is 6 volt battery which is connected like this, and a 2 ohm resistance and another 2 ohm resistance, and there is a 8 ohm resistance which is connected like this, and another 2 ohm resistance and 2 ohm resistance, again 8 ohm resistance, and this is, sorry, A, B. Okay. Now, what is the Thevenin's equivalent? The Thevenin's equivalent across A, B. That is the question. Find V Thevenin and R Thevenin. This is our question. Okay, we have to find V Thevenin and R Thevenin. So how to proceed this problem?
First, we find the R7.
B Thevenin or R Thevenin? Which
We want to find
one
both
is
V.
the
We want to find the V Thevenin and R Thevenin here for the network. Okay, if you see from here, this
Will you
side,
start with it? B Thevenin or R Thevenin?
whatever. So you see
V
this
Thevenin?
network, we can.
Okay.
The general procedure I will tell you. What is the general procedure? To find VThevenin, you have to find the voltage between A and B, right? Yes.
Yes.
After that, you have to short circuit that 6 volt and find the resistance between A and B, right?
Yes.
So if we proceed like that, in the first step, we want to find the voltage between A and B. How to find the voltage between A and B? You have applied the
8 ohm by simplify the circuit and apply voltage
you cannot
division.
how you can apply the voltage division if something is connected here? You can see here something is connected. Simply you cannot apply the voltage division. You can
Should
apply
we
the voltage division.
calculate the current?
You can calculate the current, you can do the mesh analysis, anything, but there is a simple way that I will tell you. We will break down the circuit into two parts. Okay, can you hear me, right? So we will break down
Yes.
the circuit into two parts. First, you see the line I am drawing here. I'm going to draw the line here. I'm going to draw a line here, and from this line I will see our VThevenin 1, this new VThevenin. I will simplify the circuit, and RThevenin 1. So what is the procedure for finding the Thevenin equivalent? If you are finding the VThevenin and RThevenin, you have to break it, you have to separate the load, you have to remove the load, right? So I am going to remove the load. And what is the load here? The load is nothing but this total thing is the load, right? Now, am I correct?
Yes, sir.
When you consider VThevenin 1 and RThevenin 1, so I am going to consider this is 6 volt, this is 2 ohms, this is 8 ohms. I open circuit here, this part, and this is 2 ohms, and I open circuit here. Now I will find from here, this side, I will find VThevenin 1 and RThevenin 1. What is my VThevenin 1? It's very easy now. It is just a voltage division. 6 divided by 2 plus 8 multiplied with, I want only the 8 ohm resistance. So you will get this like this. Okay. So this is nothing but 4 volt. Is it clear?
Yes.
Okay.
Now RThevenin, how can I find the RThevenin? RThevenin means I just need to short circuit this. That means short circuit. Now there is a 2 ohm resistance, again 2 ohm resistance, and a 8 ohm resistance. And I see from here, what you can see now? 8 ohm is parallel with
With 4.
RThevenin. Yes, this is 2. So 8 ohm parallel with 4 ohm. You will get it as 8 over 3 ohms. It's very simple, you see. Now I will change this part of the circuit. That means this part of the using my VThevenin and my RThevenin. Is it okay? I changed the part of the circuit.
Yes, sir.
Yes.
Yes, this is my VThevenin 1 and RThevenin 1 for the first stage. So I replace the circuit with a 4 volt. It's very easy now. So you see here 4 volt, and it is 8 over 3, I think. Yeah, it is 8 over 3 ohms. Now I will connect the rest of the part. What is my rest of the thing? It is nothing but 2, 2 and 8 again. So my 2, again 2, and my 8 ohm. I want to find the VThevenin and RThevenin here from this side. Okay, this is my point A and B. Is it clear now? Point
Clear,
A and B.
sir.
Yes.
Yes. Then it's very easy now. What is VThevenin? You have a 4 volt. Yes, just voltage division divided by total resistance is nothing but 2 plus 8 over 3 plus 8. Okay. Yes, multiplied with 8 ohm, right? So that's it, VThevenin. And what is RThevenin? It's very easy, short circuit. RThevenin is nothing but your 8 ohm is in parallel with your 2 plus 8 over 3. Am I correct?
Yes.
That's
Yes.
it. Okay, so this is how you can break down. So you can apply the VThevenin and RThevenin wherever you want, and you can simplify the circuit and use that idea to solve the bigger circuits. Okay. So otherwise, if you want to find the VThevenin and RThevenin directly, if you find directly, you have to apply the loops. You have to take this as 2 loop, and you have to solve this 2 mesh number 1 and mesh number 2. It's very complicated, you know, right? So that's why. So we have to use the trick wherever necessary. That's it. So that will only through the practice. Shall I move to the next problem?
Yes.
Yes, sir.
Yes.
So the next problem is question number 7. you have a circuit which is an AC circuit, and there is a power supply which is 30 amp. This is 1 minus J1, and another here you can see it is 1 plus J1, this much ohm, and there is another power supply which is 30 minus 45 degree. So previous was 45 degree and this is minus 45, and there is a impedance which is connected here. Okay, and this is 1 0. 1 plus J0 means what? It is a pure resistance. Am I correct?
Yes, sir.
1 ohm.
Yes. 1 plus J0 ohm means it's a pure resistance. Okay, and you can say this is the load RL. Okay, and some current is flowing through the load which is IL. You have to find the IL. Okay, use the Thevenin's theorem. Okay, Thevenin's theorem or Thevenin's equivalent, you can say. So how we will proceed now? If you want to find the current through some load, first of all, what is the first step? You have to remove the
load.
Yes, after that we will find the. So after removing the load, you will get the equivalent circuit like this, 30 angle 45. Okay, remove the load first. Remove RL. Then you will get something like this. This is removed. Load is open circuit now. Now this is 1 minus J1 ohm and 1 plus J1 ohm. Okay, and this is 30 angle 45 minus 45 here. Then this is okay. Now how you can find, this is the voltage between this point, we will call Thevenin, and between this point we will find Thevenin. Is it okay?
Okay, sir.
Yes.
Now this is Thevenin, means this is my Thevenin, I will say. Now how to find the Thevenin here? You will just apply the KCL.
Nodal analysis.
Yes, nodal analysis. Just apply the KCL. As I assume that all the currents are leaving away from the junction, as we told, and here no current, it is 0 ampere anyway, because the load has been removed already, so you don't need to consider this one. So it is nothing but Thevenin minus 30 angle 45 divided by 1 minus J1, okay, plus Thevenin minus 30 angle minus 45 divided by 1 plus J1. To simplify this, you have to use the conversion, the polar to rectangular or any of the conversion you have to use. Okay. If you convert this to rectangular, convert these things to rectangular and solve this. I am not going to solve this. I will just write the answer. Thevenin, you will get it as J30 by square root of 2, simplifying this, after simplification, minus, again you will get J30 by square root of 2. That means you will get Thevenin volt. What is? You will get exactly 0 volt. So Thevenin will be equal to, for this circuit, you will get Thevenin is equal to 0. Then what will be the current?
0 ampere.
Yes, the current will be 0. The current will be 0 ampere. Is it clear? Because Thevenin is 0, so you don't need to calculate Thevenin and all. The current is 0 ampere, of course.
So how we
So
calculate the
if
Thevenin for this question?
for this question, you can calculate the Thevenin by short circuiting the voltage source. If you short circuit the voltage sources, then these two, 1 plus J1 and 1 minus J1, will come in parallel, right? That will be your Thevenin. Is it clear?
Yes.
Yes.
Yes, it's easy thing. Okay, just do the same procedure for all the problems. The procedure will be same. Thevenin's theorem is not so difficult. Okay. And next question is a very typical question. It's a very interesting question. You have, there are a lot of some, this is question number 8, I think so. Okay. This is, there is a voltage source which is V of S. Do you know this V of S? I will introduce you later anyway. This is 1/16 Henry. And there is a capacitor which is 1 farad. Do you know V of S? S you have seen somewhere?
Laplace.
Yes, Laplace. Okay. It is in a frequency domain, actually, you can say simply. So this is a simply you can say this is a inductor and there is a capacitor. And what will be the Laplace domain of inductor? Any idea? For inductor, if you have an inductor with L Henry, you can represent it as LSL. For capacitor, you will represent it like 1/SC. We will discuss this later. Yes. So this is nothing but 1/S, because C equal to 1. Here C equal to 1. And here this will be equal to S/16. Yes. That's it. It is in the frequency domain. It is not in the time domain. Okay. Now the question
Can you
is,
repeat the last point, Doctor? How you
this is in the
convert it?
frequency domain. It is in the Laplace domain. Okay. Everything in Laplace or frequency domain, you can say. Okay. So this is the point you have to remember. Okay. Because your L will be represented as S into L and C is equal to 1/SC. Okay. Is it clear?
The inductor here, what is equal, Doctor? S/16?
The inductor is 1/16. So it will be S into 1/16. S into 1/16 is equal to S over 16. Then 1/S into C is equal to 1/S into 1, which is equal to 1 over S. Okay.
Yes.
It's clear.
It's clear
Yes.
now.
Yeah.
Clear.
Now the question is, the circuit shown in figure will act as an ideal voltage or current source between the terminals A and B when the frequency are dash and dash or dash or dash. That means the question is, you have to find at what frequency guy will act like a ideal voltage source and fill it here, an ideal current source, you have to fill it here. At what frequency, at what omega, you can say, at what frequency, at what omega, and here what is the omega. That means you can see this is a AC circuit. AC circuit will be always having frequency, right? Am I correct?
Yes, sir.
Yes. So what you have to find is that at which frequency, at some frequency, this circuit will act like a current source or a voltage source, whatever, which is ideal. Ideal means what? There is no source resistance. Am I correct?
Yes, sir.
Yes. So what we will find, we will change this network. At first, we will change this guy into V Thevenin and R Thevenin. R Thevenin means your Z Thevenin. Am I correct? Between the point A and B. Is it okay? And this is
Yes,
nothing
sir.
but Thevenin equivalent. And we will find the Norton equivalent also, because we want to find some information regarding the current source also. So this is I Thevenin and this is R Thevenin between the point A and B. Now when this become ideal, what is the situation in ideal?
when the Z Thevenin equal to 0.
Yes, and it become ideal here when R or Z Thevenin. Okay, Z Thevenin become infinity. So we will find these two cases. That's the question actually. So first of all, we will find V Thevenin and R Thevenin. Okay, what is V Thevenin and R Thevenin here? Not V Thevenin. V Thevenin is not required. We just need only the information regarding Z Thevenin, right? Am I correct?
Yes,
We want
sir.
to find only what is Z Thevenin. How to find the Z Thevenin here?
The inductor parallel to the capacitor.
That's it. So inductor is in parallel with the capacitance. That means you have Z Thevenin. Your inductor is S by 16, which is parallel with 1 over S. So you will as S over S square plus 16. And you might have heard about in Laplace transform, if you want to find, if you need to find
Inverse Laplace.
no, not inverse Laplace, I'm not talking about, if you find the frequency response, if you want to find it as a function of frequency, just put your S equal to j omega, substitute there S is equal to j omega. So Z Thevenin, okay, this is the Z Thevenin as a function of S actually. You can say this is the function of S. Now we will find Z Thevenin as a function of S is equal to j omega. Okay, I am putting S is equal to j omega. That means Z of Z Thevenin of j omega,
It has
which is
to be
nothing.
sigma plus j omega.
But we are not interested in sigma because we are interested only in the frequency. We are not interested in the amplification factor
So ignoring
because we are
the
interested.
real part.
Yes, you can see S is equal to actually sigma plus j, and the sigma is actually the amplification part actually, or the attenuation part, and this is the frequency. And we are interested only in the frequency because our question is at what frequency. Clear?
Yes, doctor.
Okay, so we will just put S is equal to j omega. There are a lot of things to be explained about the Laplace domain. Inshallah, if time permits, inshallah, I will explain to you later. Okay, now
Minus
this
1
is,
omega square.
yes, 16. So this becomes j omega by this is minus omega square because j square is equal to, okay. Now you have two cases, Thevenin's equivalent and Norton's equivalent. Thevenin's equivalent and Norton's equivalent, and the equation for Z is now it's very clear. Z Thevenin. Thevenin equivalent will give you ideal source when Z Thevenin is equal to 0. So Z Thevenin equal to 0 implies j omega by minus omega square plus 16 equal to 0. Then what is the frequency?
Omega equal to 4.
0.
Yes, it is equal to omega equal to 0. Omega equal to 0 means frequency is equal to 0 means what is it? Frequency is equal to 0.
Z Thevenin equal to 0.
Z Thevenin equal to 0 means frequency is equal to 0. We are talking about the frequency. Frequency is equal to 0 means which kind of wave? AC or DC?
DC.
DC.
DC, right?
Yes.
Now I will redraw
Yes,
the
sir.
circuit. You see, I am going to redraw the circuit. This is our circuit. I connect a DC. If I connect a DC, you see here, I connect a DC and you have an inductor and a capacitor. Here I connect omega equal to 0 here. Then what is this? The capacitor will be open circuit for a DC. You know this, right?
Yes.
And
Yes, sir,
inductor
yes.
will be short circuit. Inductor
Short
will be.
circuit.
Then you see here, this is a voltage source just like this. What is this? Ideal or not?
Ideal.
It is ideal. That's it.
Ideal.
Yes. You see, from the mathematics, actually, we are getting the physical representation. So you should be able to relate the physical thing with the mathematics. Okay. Whenever you see some equation, you should be able to relate it with the physical situation. Now you see the Norton equivalent. In the Norton
Doctor.
equivalent, yes,
Excuse me, I have a question, doctor.
yes,
Here, when you find
yes,
the Z Thevenin, why
yes.
you remove S and put J omega? Why not
Because
put
in
it as
general,
S?
yes, I will explain in the next slide after finishing this. Okay.
Inshallah, doctor.
Okay, sure. Now you see here, Z Thevenin equal to infinity means there is not an equivalent. So Z Thevenin infinity Z Thevenin, what it will be?
Open circuit.
Infinity, Z Thevenin is infinity. What it will be?
Open. Open circuit.
Okay. Z Thevenin is infinity means it's an open circuit. Okay. So Z Thevenin is equal to infinity. That means minus omega square plus 16 should be equal to 0 from this equation. Am I correct?
Yes, sir.
Yes. So what it will be? It will be omega
Gonna
is
be
equal
4.
to 4
Plus minus
and
4.
it is 4 radians plus second. Okay. Yes, frequency is plus or minus 4, but usually we will take the plus 4 frequency because what is the reason for this? You can move clockwise or anti-clockwise. That's the reason actually. That is a there are a lot of phenomena which is related to that. Dr. Usman, you know Dr. Usman?
Yes.
Yeah, Dr. Usman has made a beautiful Dr. Usman has made a beautiful video in the YouTube. Inshallah, I will get the link from him and you can watch it. What is the meaning of the positive and negative frequency? Okay. So you will get here plus or minus 4. So you can watch it. Anyway, I'm not going to explain it now. Okay.
Okay, sir.
So this is the case for an ideal current source. Okay. Now we will see the next problem, question number 9. I will give to you. You can find the Thevenin's and Norton equivalent. Oh, sorry, I forgot to explain about this, the Laplace. Okay. Okay. You know this,
Yes,
the Laplace transform. If you have a function x of t, the Laplace transform of x of t is nothing but it is represented x of s, and this s is equal to sigma plus j omega. You remember this?
It is for first time,
This,
doctor, for me.
yes, first time.
Yes, first time.
How it?
I have studied Laplace, but the mathematics. The mathematics.
Okay, I will
but
just
I don't
give the.
study like this.
Okay. So in the what is the? Okay, there is a lot of things to be said about the Laplace transform. Okay, I don't know how to explain to you in 5 minutes. Inshallah, I will try my level best. Okay, it's a big theory. The Laplace transform x of s of a function x of t can be found out. Just multiply it with e power minus st and integrate from minus infinity to infinity. Okay, and this is nothing but your Laplace transform, and it will be a function of s. And this is known as actually bilateral Laplace transform. Bilateral Laplace transform. Have you heard about this bilateral?
Bilateral, yes.
Bilateral means two sides. Yeah, two sides. It is yes. It is going from, it is including positive side and negative side. This is your zero center. Okay?
Yes.
Your zero. That's why. But you know that for a physical system, a real-time system, if you consider a physical system which is a real-time system, for a real-time system, physical system, you might have heard about causal system. Have you heard about this causal system in your signals, digital signal processing class?
Yes, causal, yes.
Yes. A causal system is having a feature that the value of, suppose x of t is a causal system or a causal signal, x of t will be defined only between 0 and infinity. For that means x of t is equal to, is a function of time. That means it is for greater than or equal to 0, and the value of x of t is equal to 0 when t is less than 0. That means for negative values of time, the value for the negative values of time, x of t is not defined. That is known as a
Step
causal
function.
system. Yes, yes, like step function. So x of this is bilateral. So the unilateral means our integration will be only from 0 to infinity, x of t e power minus st dt. And this is known as the unilateral Laplace transform, or we simply call Laplace transform. This is what you have studied actually. Okay. In mathematics, sometimes you will see like this. But in a physical system, because in a physical system, there is nothing before t less than 0. It is meaningless because we have no prior idea about the system. That's why. So if we are defining something t less than 0, that means it cannot be a causal system. And in a physical systems are all causal systems. That's why our Laplace transform is e power minus st. And do you know what is this e power minus st?
I have heard about it before.
It is nothing but using Euler's identity. This is an identity which is defined by the scientist. Okay, Euler's identity. It is nothing but cos st minus j sine st. And your s is nothing but a complex number. It is a complex number. Why we are defining it in a very complex way? Because there is some simplicity in some domain. Anyway, you can see here sigma plus j omega. Sorry, yes, sigma plus j omega. So you can see here, this is the real part, and this part is nothing but the imaginary part. Okay, so you can represent e power minus st is nothing but e power minus sigma plus j omega into t, which is nothing but e power minus sigma t plus e power, sorry, not plus, multiplied with e power t. You can see this is a number. That means it is an attenuation factor. Attenuation, or the amplitude, you can say. It is nothing but the amplitude. And this is nothing but, what is this? It is nothing but cosine omega t minus j sine omega t. It contains two things. It contains two things which are acting perpendicular. That means you can see one is acting in cosine direction like this, and other is in minus j, minus something like this. So cosine omega t is acting in one direction and minus sine omega t, this is, or we can say sine omega t is acting in direction of minus j. So this is the direction of 1 and this is the direction of minus j. So both are acting in a perpendicular way. And you can see this amplitude is e power minus sigma t. It is nothing but an amplitude like this, which is going like this. Okay, am I correct? This is the graph, e power minus sigma t. Is it okay? I am considering only the positive. I am considering only the positive side. You know, my integration is starting from 0 That's why I'm considering only the positive side. Okay.
Yes.
Now, e power minus j omega t is nothing but your cosine omega t minus j sine omega t. So you can have power minus sigma t into e power minus j omega t is equal to e power minus sigma t into cosine omega t, okay, minus e power minus sigma t into sine, sorry, j is the sine omega t. So this is my real part and this is my imaginary part. If I plot my real part, you know this is a cosine wave which is multiplied by power minus sigma t, and you know this is e power minus sigma t. I have already told you it is a wave like this. So you have e power minus sigma t like this multiplied with the cosine omega t. This is your cosine. So what will be the result? The result will be something like this. It will be decaying cosine. That means a cosine function which is decaying like this. Am I correct? And this is the imaginary part. If I take only the imaginary part, you can see here, this is e power minus sigma t and multiplied with sine function. Sine function like this. So it will be a decaying something like this. Okay. A decaying sinusoidal. So we are representing our signal. You can see here when I do this kind of operation, that means if I find x of s, which is nothing but integral 0 to infinity x of t multiplied with e power minus st dt, what I am doing, which is nothing but integral 0 to t x of t into e power minus sigma t multiplied with cosine omega t minus j into e power minus sigma t multiplied with sine omega t. So you can see here in the previous slide, you can see here this part showing only the amplitude. This part is showing the amplitude. And where is the frequency? The frequency is in the sine or cosine wave, right?
Yes.
If you put sigma equal to 1, if you put sigma equal to 1, then what will be it? It will be just a step function. Is it clear?
Yes.
Then 1 multiplied with this one, what will be the result of this? It will be a single frequency, just a frequency, right? Cosine wave or sine wave. So if you, not sigma equal to 1, sorry, sigma equal to 0, I forgot. Sigma equal to 0 means e power 0 become 1, right?
Yes, yes.
Yes, that's why the previous problem I put sigma equal to 0. When sigma equal to 0, just j omega, then I can focus on the frequency. I can focus not on the amplitude, I can directly focus on the frequency, whatever be the amplitude.
Yes.
My amplitude, I put it as 1 actually, or sigma equal to 0. That's why. If I want to focus on the frequency only, I have to put sigma equal to 0.
J omega.
Is it clear? Is it clear?
Yes.
If you give me some 10 minutes, I can give you some more physical explanation of this. What you say,
Take your time.
according to you. Anyway, then I will stop the problems for today now. Okay, inshallah, we will continue for the problems in the next class, but I will give you some more explanation regarding Laplace. I will give you the physical interpretation. Yes, I will give you the physical interpretation. Okay, what is the physical meaning of this?
Okay, sir.
I am doing some nonsense mathematical things, and you may feel like why I am doing like this. That is the main point. We are actually, have you heard about something known as projection in mathematics? Projection.
I don't think so.
Okay.
I have no idea, sir.
Suppose, okay, the simple thing is nothing like this. You have an x-axis and your y-axis. Suppose you have a vector which is x1 and y1. That means it is like this. It is a straight line which is a vector. Now you want to find what is the component of this vector along x direction. What is the component of this vector along x direction? It is nothing but x1. What is the component of this vector along y direction? It is y1, right? So you are splitting a vector. Vector means it is having a magnitude. It is having a magnitude. And what is the magnitude of this vector? Can you tell me? It is nothing but
x1
square root of x1. Square root of x1 square plus y1 square. Pythagoras. It's clear?
Yes, sir.
Yes. So you can define in another way also. You can define this as norm of this. Norm of your x1, y1. We will call it as the x1 square plus y1 square. And if you want to find magnitude, just take the square root of this. That's it. And what is x1? If you know the angle between this, suppose this is theta, the angle between the vector, your vector, this is your vector actually, your vector, and x-axis is theta. And what is x1 in terms of theta?
So
Sine inverse.
Not sine inverse, just to simplify it. You see here, this is your x1, and this is your magnitude. This is, let's say, this is y1, okay, and this is your theta. And what is your cosine theta? Cosine of theta is equal to adjacent side by hypotenuse. Yeah, cosine theta is x1 by r,
x1
right?
by r. Yes.
Yes. So what is x1? It is nothing but r cosine theta. So it is nothing but r cosine theta, and r is nothing but the magnitude. Similarly, y1 you will get r sine theta. Am I correct? So you can represent anything, any vector, in terms of another things according to its coordinates. Yeah, you can represent anything, a signal, in terms of another signal. For example, you have a signal which is 1. Always it is 1. This is your signal x of t. You can decompose the signal. Let's say this is 10, not 1, it is 10. You can decompose the signal like this. You have a signal like this, plus another signal which is just opposite. Okay, sorry. This is your signal, and your another signal which is okay. This is 1, this is 1, 1. This is 1, this is 1, like this. So can you decompose the signal into two parts?
Yes, a straight line.
You see here, this is, you just multiply this with a coefficient 5. Let's say this is a1, this coefficient is equal to a1, and let's say a2, you multiply with 5. Let's say a2 and multiply with 5. Then what we will get, if you add this two guys, if you add these two guys, what you will get? You will get 10. Is it okay?
Yes.
Yes, sir.
But how would you find the amplitude is 5? Not 5, sorry, it is 10. Sorry, it is not 5, it is 10. This is 10 and this is 10. So 10 into 1 is, it is something like this. It is 10, 10. And what about this signal? You multiply with 10. Sorry, not this one. It's like can you get my point? Are you getting my point? You can see here, if I add these two signals, I will get my original signal.
We separate
So I will call this
signal into two.
Yes, we are separating the signal into two. We will call this as the basis. Basis means what? a small element, we can say. You know that if you have a big material, you can decompose into small atoms like this. So this is the basis number 1, and this is the basis number 2. You got it? Now, if I want to find, and what is the coefficient of basis number 1? It is A1. And what is the coefficient of basis number 2? It is A2. And in this problem, you got A1 is equal to 10 and A2 is equal to 10. Got it?
Yes.
Now, how to find A1 and A2?
Yes, sir.
How to find this? You have the signal, original signal is x of t, which is equal to 10. And you have the basis 1. I can see the signal B1 is like this. And you have the signal B2. Your signal B2 is like this. How you will find this A1 and A2? From this, you have to find A1, how much? What is the coefficient? From this, you have to find A2, how much is the coefficient? You can find this, just multiply your signal x of t, you multiply with B1 first. If you multiply your x of t with B1, if you can see like this, your signal is like this. So if you multiply with B1, if you multiply with B1, you will get how much? You will get like this, 10,
10 but
10.
multiply by 10.
Yes, everything will be 10, 10, 10, 10, like this. Similarly, if you multiply your x of t with B2, then you will get something like this here, which is 10. This is 1, this is 1. So you will get something like this, 10, 10, like this. Got it?
Yes, sir.
Now you can see here, now you can represent this. You can see your coefficients somewhere. If you take one cycle, what is its average value? It will be 10. So you can see the coefficients here. You can see your coefficients here, your A1 and A2. Like this, you can decompose any signal into different another signals. That means you can combine a lot of signals. The original signal. So if you have a signal, I am going to conclude it. I will not take much time because at least 3 to 4 hours lecture is required for this. That's why. If you have a signal like this, you will decompose this signal as the sum of another signals. This plus, like this. Infinite number of signals. You understood? So
Yes,
this is
sir.
your first basis 1, B1 of t, and this is B2 of t, and this is B3 of t. So you can combine. And what is the coefficient? Your coefficient is A1.
A1, A2.
This is coefficient is A2. This is A3. If you add all these things, that means A1 into B1 of t plus A2 into B2 of t plus all this. If you add, you will get the original signal, x of t. You understood?
Yes.
Yes.
So in Laplace transform, you are actually finding the Laplace transform of a signal which is x of t, which is equal to x of s. It is nothing but it is 0 to infinity x of t into e power minus st dt. So you can see, instead of our b of t, b1 of t, b2 of t, b3 of t, we have b of t. In general, it is nothing but your e power minus st. That means your small functions are generally represented by using e power minus st. You got it? What is this e power minus st? It is having a real part, and it is also having a imaginary part.
Yes.
And the real part is this one, and the imaginary part, you know, this imaginary part, it will be a sinusoid, right?
Sinusoid.
And this is your, this frequency is omega. If you change, you can change the frequency and you can change the sigma, then you will get many b of t's. Got it?
Yes.
Yes,
For
sir.
different values of sigma. And yes, so you can get many b of t's. And instead of your a, what is your a now? Since you have infinite values, infinite b of t's, and what is nothing but, it is nothing but e power minus st. Since s is a function of sigma plus j omega, you can change this, you can change omega and sigma, you will get many infinite number of s, infinite number of values for s. That means you will get infinite number of a. Are you getting my point? You will get infinite number of a's also, because you have infinite number of s. So for each, you see here in this example, for b1 I have a1. Like this, for each value of sigma, for each value of sigma, for each
You will have a
sigma and j omega, we will be having a b of t, that means e power minus st, and for each of this we will be having a coefficient, right?
Yes.
We will be having a coefficient, and this coefficient we can say it is also a function of s, and this coefficient is nothing but your Laplace transform. You got it?
Yes,
This
sir.
coefficient, yes, you are dealing with the coefficient. So how to find the coefficient? I told you, you have to first multiply. So you are multiplying your original signal, you are multiplying your original signal with e power minus st dt, and you are integrating. Integration means adding everything. Adding everything is a part of average. You know how to average something. If
Yes,
there are
add
two
and
students in a
divide.
class,
addition over its number.
adding and divide. Yes, adding and divide. That is the, and division is not explicitly shown here. If you are adding everything, you are getting some number which is nothing but your coefficients, x of s. So x of s is nothing but your coefficients. As I shown in the previous example, it is nothing but your coefficients. How much factor? You understood? So you can see the signal now in a beautiful way. That means you are actually decomposing a signal into many parts. If you decompose a signal into many parts, then you can see each signal, right? Each frequency, you can see each frequency. Am I correct? This idea is nothing but the Laplace transform in brief. This is what I can explain within some 15 to 20 minutes. If you want any more explanation on this, I can give you some 3 to 5 hours lectures, inshallah. Okay, according to your requirement. Okay, inshallah, we'll see in the next
Okay,
class.
sir.
I
Thank
hope
you,
that
sir. Thank you.
this is very brief. Okay, there are a lot of beautiful things regarding this. You
Inshallah,
can see some YouTube videos also, but there are a lot of beautiful things related to Laplace transform. But it requires a lot of time. That's why. Okay, inshallah, we will see tomorrow. Inshallah.
Inshallah,
Assalamu
doctor.
alaikum.
Thank you, doctor.